Hey everyone, tonight the last video that you're going to have for your statistics unit is on mean absolute deviation. Mean absolute deviation is a way of measuring how spread out our data is. So similar to the interquartile range or the range, it helps us to see if our data is really close together, if we have a small mean absolute deviation, or if we have a very large mean absolute deviation, that means our data is very spread apart. So not very close together, not very consistent. So similarly, if you've got a very wide range, a large range, that means that your data responses are sort of all over the map. There's a lot of different answers. Whereas if you have a very small range, that means that your responses are very similar. They're very close together. With mean absolute deviation, it's a little bit more complicated than range or interquartile range, but it also is a little bit more accurate. So the steps we're going to follow for calculating mean absolute deviation begins by calculating the mean. So let's begin there. We'll calculate our mean for this set of data. 6 plus 4 plus 6 plus 3 plus 8. So 6, 4 plus 6 plus 3 plus 8. And then when we're done adding those up, we're going to divide by 5. Okay. So I notice here, this is going to give me 10 plus 6 is, or 16 plus 3 is 19 plus 8 is 27. That's going to be 27 divided by 5, which I know is 5, and 2/5, or 5.4. Okay, so our next step is that we need to find the absolute value of the difference between each number in the data set and the mean. So let's start by writing down our mean from the last slide, which was 5.4. And we need to write down our list of data, which was 6, 4, 6, 3, and 8. So we need to find the absolute value of the difference between each number and the mean. So the absolute value of the difference between 6 and 5.4, we need the absolute value of 4 minus 5.4, another 6 minus 5.4, 3 minus 5.4, and 8 minus 5.4. All right, so now let's simplify each of these. 6 minus 5.4 is simply 0.6, and the absolute value of 0.6 is 0.6. The difference between 4 and 5.4 is going to give us negative 1.4, and the absolute value of that is just 1.4. The absolute value of 6 and 5.4 again is 0.6. 3 minus 5.4 is going to be negative 2.4. And the absolute value of that is positive 2.4. And then 8 minus 5.4 is 2.6, which the absolute value of that is simply just 2.6. All right, and our last step is to add the absolute values together and then divide by the number of data points. So to do this, we're going to need to add all of our absolute values together. So that's 0.6. There's another 0.6. We had 2.4, 2.6, and a 1.4. So when we add all of these together, what we should get is, let's see, there's going to be a 6 here because that comes out to 26. I'll carry that 2. 2, 2, 2, and 1 is 7. So I have 7.6 as the sum of all my absolute values. And then when I do 7.6 divided by 5, bring up my decimal point, 5 goes into 7 one time. 1 times 5 is 5. That gives me 2. I'll bring down the 6. 5 goes into 26 5 times. That's 25. 1, I'll add a 0 there. That's 2. And I'm done. So my mean absolute deviation is 1.52. And that's relatively small absolute deviation. We'll see some absolute deviations that are much, much larger, some that are fairly small, but this is actually a quite small deviation, which would mean that our data points are actually pretty close together. And considering that we have a small list and all of those numbers are fairly small numbers, that's to be expected. All right, now once you have worked through this problem and you feel pretty comfortable with it, go ahead to the iExcel assignment on mean absolute deviation and see if you can try calculating it on your own.